To find the arc length and the area of the sector, we need to have the degree in radian. Very important that it's in radian. In this case, for number 15, it's already in radian. So we have our arc length, which is S, equals r theta. So the arc length equals 4 times pi over 6, which turns out to be 4 pi over 6. You could reduce that down to 2 pi over 6 if you wish, but remember that's not an angle. So we would say 4 times pi divided by 6, and we get an arc length of 2.09. And those would be in inches. The area of this sector would be half of r squared theta. So the area equals half of 4 squared times pi over 6. So half of 16 times pi over 6, which is 8 times pi over 6, which we could call 8 pi or 4 pi over 3, but remember that's not an angle. So we're going to say 8 times pi divided by 6 gives us 4.19. Those would be inches squared because it's area. The sector, S is arc length, is radius times your angle. Now the angle has to be in radian. This is not in radian. So we've got to take 25 times it by pi over 180. 5 goes into 25 5 times pi. 5 goes into 180 36 times. So that's 5 pi over 36. So we would say 18 times 5 times pi divided by 36. That gives us an arc length of 7.85. And those are in meters. And then the area is going to be half 18 squared times 5 pi over 36. That's 324 times 5 pi over 36. Well, that would be half times 18 squared times 5 pi divided by 36. If you want the numerator to be completely calculated together, that's a way you could do it. You get the same answer either way. 70.69 meters squared. Remember, that's a larger radius of 18 rather than the smaller radius of 4 we had on this side. So the area is naturally going to be bigger. This angle was 25 degrees. This one here is 30 degrees. So that's pretty close. So it's just the size of the radius which has really stretched this one out. Number 17. The steepest hill for the Magnum roller coaster at Cedar Point has an angle of elevation of 55 degrees with the ground. this hill stretches out a horizontal distance of 150 feet. How high is the steepest hill? So if we're going to say 55 degrees and a horizontal distance of 150 feet, what is the height? Well, that would be opposite and adjacent. So that's tangent of 55 equals the opposite over adjacent, cross multiply, 150 times the tangent of 55 equals the height. So be sure you're in degree mode, and 150 times the tangent of 55 comes out to be 214.22. The height should be around 214.22, and these units are in feet. A car drives on a ramp in order to enter a parking garage. The ramp has a height of 4 feet and a horizontal length of 20 feet. What is the angle of elevation? So 4 feet is your height. The horizontal is 20 feet. What is the angle of elevation? So the tangent of theta is going to equal opposite over adjacent. You could reduce that fraction if you wish. The tangent inverse of 4 over 20. Tangent inverse of 4 divided by 20, you have to have parentheses here, comes out to be 11.31. So that would be the degrees of the angle of this ramp. In the shot put event in 2004 Summer Olympic Games, the winner shot was 21.16 meters. For a shot put to be fair, it must land within a sector with this given angle. So 34 degrees would be something like that, maybe. So that would be the angle. If the officials drew an arc across the fair landing area, marking the furthest throw, how long would the arc be? So we're looking for the arc length in this case. We know what this angle is. We know what 21.16 is our radius. So R equals 2116. Theta equals 34.92 degrees. Well, we need to put degrees into radian. So that's going to be the angle, and then we're going to times that to 2116. So the sector area equals 2116 times 3492 pi over 180. If you'd like to calculate what 3492 pi divided by 180 is, that gives us this 0.6095, but we'll take that value and multiply it to 2116. And those would be in meters. if the fair shot put in the 2004 Olympics landed in the sector bounded by the arc, what is the area of the sector? Well, we know the radius is still 2116, and the angle is going to be 3492 pi over 180. That's the exact answer. That's why I keep using that rather than using some rounded number like 0.6095. The area, that's the angle. Let's call that theta, not A. It could be complicated, so we'll do theta. A equals half r squared times theta. So the area equals half 21.16 squared times this 3492 pi over 180. So we're just using the same formula like we always have. We have a funny looking radius and a funny looking angle, but it calculates just the same. So we say 0.5 times 2192 squared, because that's our radius. Oh, I'm sorry, 2116, and we have 3492 pi divided by 180. 136.44 meters squared. That would be your area. You should expect that the area is going to be larger than the arc. In most cases, that's true. The wheel of a unicycle completes 6 full revolutions. Through what angle, in degrees and radians, has the wheel rotated? So there we have a unicycle. Something like that. Never rode one. And if that's going to go around 6 times, that's going to be 360 times 6. Times 6 gives us 2160, and that's degrees. Now we could convert that to radian, but we also know that a radian is 2 pi, and that's going to go around 6 times. That should give us 12 pi. So that would be a radian. You can put the word radians next to it if you like to give it a label. The escalator at the Mall of America in Minneapolis, Minnesota, has an angle of elevation of 30 degrees. The length of the escalator is 210 feet. What is the height? $30 degrees, 210 feet. What is the height? Well, this is a 30, 60, 90 triangle. We've learned about 30, 60, 90 triangles. We know that the hypotenuse equals the short leg times 2. So if the hypotenuse is 110, then the short leg, which is the height in this case, we're going to divide by 2 to get 105 for the short leg. Another way you could look at it is the sine. The sine of 30 equals opposite over hypotenuse, and when we cross multiply, we're going to get the same exact answer. 210 times the sine of 30 gives us 105. And those would be in feet. Either way you like to think about it. Okay, on our third page, we should be able to do these calculations without a calculator. We're looking for the 6 trig functions. So at 135, we have root 2 over 2 and root 2 over 2. So I know that sine of theta, sine of 135 actually, is root 2 over 2. The cosine is root 2 over 2. Well, isn't the cosine negative root 2 over 2? Because it's in the second quadrant. Tangent of theta would equal negative 1, because it would be sine over cosine, and one of those is negative, so you get a negative 1. Cosecant of our theta is going to be the reciprocal of that, so that's 2 over root 2. And then you rationalize the denominator, which gets us 2 root 2 over 2, which is just 2. Secant of our theta is going to be negative root 2. And cotangent of our theta is still going to be negative 1. The 6 trig functions at 3 pi over 2. 3 pi over 2 is straight down, so that has a coordinate of 0, negative 1. The sine of our angle is negative 1. The cosine of our angle is 0. The tangent of our angle is sine over cosine. Here, let's put down negative 1 over 0 and then call that undefined. Secant of our theta is the reciprocal. Oh, that's cosecant. Secant of our reciprocal is 1 over 0, which is also undefined. And then cotangent is the reciprocal of this, which is 0 over negative 1, which is just 0. We're going to evaluate for the cosine of negative 210. So think about your unit circle. Negative 90, negative 180, that's 30 degrees more. It's negative 210 degrees, so I know I'm a long way short way. Negative root 3 over 2, 1/2. So the cosine is going to be negative root 3 over 2. Okay, tangent of 8 pi over 3. That's 1 over 3. 2 over 3, 3 over 3, 4 over 3, 5 over 3, 6 over 3, 7 over 3, 8 over 3. So we have 8 pi over 3. We can also call that 2 pi over 3. That would be your coterminal. And that is a short distance and a long distance. We know that's a reference angle of 60, so I know that's going to be negative root 3. But just for fun, I will show us how that comes about. We get root 3 over 2 over negative 1/2. That's the coordinate for 2 pi over 3. So we take our root 3 over 2 times negative 2 over 1. and that gives us negative root 3. All of the 60-degree angles will be a root 3 format for tangent. All the 30-degree angles will be a root 3 over 3. So the sine of 240, or I'm sorry, 840, negative 840 even. So we're going to go negative 360, negative 720, 720 plus 90 is 810, and now we're going to go 30 degrees extra. So that's actually 60 degrees here. So that's a short way over and a long way down. Notice I didn't do any converting. So we're supposed to look for the sine. So this is going to be negative root 3 over 2. Here we need to evaluate in degrees and radian. So what angle has a sine of 1? So we're supposed to look at quadrants 1 and 4. This is 1, 0. That's where cosine is 1. 0, negative 1. That's where sine is negative 1. So up here is where sine is 1. So sine inverse of 1 equals 90 degrees, or sine inverse of 1 equals pi over 2. Let's look at cosine. What angle has a cosine of negative a half? Well, we know that cosine uses quadrant 1 and 2. Half means we go over a short way and up a lot. So that's going to be up here. That's at a 60-degree angle. So reference angle. So that means 60 here and 60 more is 120. So cosine inverse of negative 1/2, that puts it in the second quadrant. So that's going to be 120. Or you could say that the cosine inverse of negative 1/2 was 2 pi over 3. Last one. Where is tangent 1? Well, tangent, remember, uses the first and the fourth quadrant. This is a positive tangent, so I know it's going to be in the first quadrant. The only spot that tangent has a y and x that are exactly the same is with root 2 over 2, root 2 over 2. So that's going to happen at 45. So tangent of negative 1, or tangent inverse of 1, is 45 degrees. Or you could say that the tangent inverse of 1 is pi over 4. Good luck on your quiz.